Hey GED students, it's GED question of the daytime, and today I'm asking you to rewrite each of the following as an equation featuring the inverse operation. A really weird request on my part, but I have a method to my madness. Really want you to be able to do this skill so that you'll be good at algebra. Turns out a huge piece of solving equations, which is you'll have to do all over the GED, is understanding inverses. So whenever you work an inverse, what you're going to do is take what used to be the answer and have that get worked on. Okay, so we're going to start with this number 9. Now what we want to do is we want to be able to take 9, do something with 6 to get us back to where we started, 15. And what we're going to have to do is the opposite of what happened before. Well, what happened before? Subtract. And so what I'll do is I'll add. I'll add on the 6 this time. 9 plus 6 is equal to 15. Now that's not the only equation you could have written. You could have flipped the order. 6 plus 9 is equal to 15. That's still an inverse of this same fact. And that would have totally worked. But I like going in the order exactly backwards. It makes it easier and students make less mistakes. And so this is the one I'd probably give. But either one would be equally as correct. So let's do the same thing again. So again, the inverse of addition is going to be subtraction. So I'm looking to start with what would have been the answer, 26. Subtract out a number to get me back to one of the numbers inside my problem. So it's true that 26 minus 2 is equal to 24. Again, not the only one you could have written. One more option. You could have also started with 26, taken out the 24, and gotten us back to 2. Either way, we did some work on what used to be the answer, chose the opposite operation, and rewrote this equation using different numbers. Using the same numbers but a different operation. Okay, now let's try C. C, now this freaks students out because they're like, dear God, a fraction. But be careful, this isn't really a fraction problem. This says 14 divided by, remember a fraction bar means divided by, 7 equals 2. 14 divided by 7 equals 2. So if I wanted to rewrite this using the inverse operation, I'd have to rewrite it using multiplication. So using multiplication, 2 times 7 is 14. I could have written it with the times sign, 2 times 7 is 14, or I could have changed the orders of the numbers, 7 times 2 is 14. But I hope you all get the idea there. All of those would be correct answers. Now let's look at the next one. 3 times 9 is 27. Well, again, if I were using the inverse operation, the opposite of times, I hope you guys know that when two numbers are shoved together with nothing between them but parentheses, they're multiplying. So we'll do the opposite of times, the opposite of multiplying, which is dividing. So we'll start with the 27, and we could divide by 3 and get 9. Or you could have taken 27 divided by 9 and gotten 3. Either one would be an inverse operation, and it's totally acceptable if you, like a mathematician, used a fraction bar rather than an elementary divide by symbol. So I would have accepted any of these as well. 27 divided by 9 is 3. Any of these 4 would be perfectly legit inverses of D. Okay, now let's look at E. I've had students do some interesting things here. They weren't wrong. They just weren't doing exactly what I asked. A lot of students said the opposite of 7 squaring is to divide 49 by 7, and you'd get 7. But that's interesting because they have another 7, one more 7 than what I had. And it's because they didn't use the exact inverse. What they did was they went, oh, 7 squared is the same as 7 times 7. And then they found the inverse of that. If that's you, it's not that you were wrong. But I do want to point out that there is an easier, more direct way to do this problem. There is just a straight up opposite of square. The opposite of square is square root. So what I'm going to do is start with what used to be the answer, 49. I'll take the square root of that, and that'll get us right back to 7. And that is the quickest, easiest way. The exact inverse of squaring here is square rooting. So this is the answer I was looking for based on the directions that I gave you. Sorry guys, math usually behaves for me, but English doesn't always, and apparently my mouth is not working today. So based on the directions I gave you, this was the inverse I was looking for because the inverse of square is square root. Great. If you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.